So now let's go ahead and talk about APIPA and our public versus private IP ranges. Now, when we're talking about APIPA stands for Automatic Private IP Addressing. Now, well, what is APIPA? When do we use it? Well, APIPA is an address which is automatically assigned to our computer for an IP address when it isn't receiving any DHCP information. We talked about how DHCP is when our computer is automatically receiving IP address information, DNS information, default gateway information. Essentially, our computer is receiving the information it needs to assign an IP address. When our computer is not receiving that information, or if we do not have a static IP address assigned, we still need to get an IP address of some sort. So if at all possible, we could try to communicate with other computers. This is where APIPA comes in. APIPA will automatically assign us a private IP address of 169.254.something.something. Now this is only when DHCP is unavailable. So if we see we have an APIPA address and we're supposed to be getting an IP address from our router or our DHCP server, that means something is wrong. So we need to check our DHCP server, we need to check our router and see if DHCP is turned off, or maybe we're not making that connection. Sometimes we may need to check our cables, we need to check our configuration on our devices and see why we're getting our APIPA address. We can find this address, we can find if we're getting an APIPA address simply by opening a command prompt and typing in ipconfig and seeing what IP address we're receiving. And if it's anything within this 169.254 range, then we know that we're getting an APIPA address, which is not good. It's not going to let us route outside of our network. We can't use an APIPA address to connect to the internet. The only computers that we'll be able to talk to, hypothetically, if we're actually able to talk to our different network devices, would be the other local computers on that our particular internal network within a router, if those computers are also getting an APIPA address. But if they have a standard address, then they're not going to be able to talk to us. So we need to make sure that if we're getting that APIPA address, we want to resolve that issue as soon as possible. Now, our other topic is going to be our public versus private addresses. Now, what's the difference between a public and a private address? Well, let's say we have a home network. So we have our laptop and we have our desktop, and these are in our home network. Well, with a public IP address, anyone in the world could reach us because a public IP address is a singly unique IP address for a computer somewhere in the world. A computer, a server, a router. It's an IP address which is a one-to-one connection. So a public IP address is globally routable. You can reach that IP address across the globe. So we don't really want our laptop, our servers, our phones, well, every single one of our particular devices that we're connecting to our little wireless network to have their own public IP address. In addition to not necessarily wanting them to all have their own public IP address so they're reached around the world, we can't give them their own public IP addresses. We've talked about how we're running out of public IP addresses. We've pretty much run out of public IP addresses just to give to anybody. And if we gave every single device in the world a public IP address, we would have long since run out of those public IP addresses to give. So we don't do that. We don't give every single device a public IP address. We have globally routable, globally unique IPv6 addresses that are in development that we could give every single device. But as far as IPv4 goes, we don't give every single device a public IP address. What we do give devices are private IP addresses. Now, private IP addresses are IP addresses that can be reached directly within a network. So inside of a router border, we can reach these addresses. So we have our laptop, we have our desktop. Let's expand our house a little bit here. And we have our router. Now, our router is connecting all of these devices internally. And our router also talks to the internet. So we have the big internet up here. And our router also talks to the internet. Now when we're talking out on the internet, we're talking to devices that have public IP addresses, as we mentioned before, because those IP addresses are routable, which means they can go through routers, they can traverse different networks. But our internal components are not. They have private IP addresses. Those private IP addresses are not routable. They provide a little bit of security. They also let us have more public IP addresses. So these are private addresses. Now our router does have on its external interface, it does have a public IP address. Now, your internet service provider may swap this out every once in a while, or you may have a reserved public IP address or a couple hundred for your business or for your enterprise. It really depends on the scale and the magnitude of your enterprise. So our router here has a public IP address. So it has an external facing public IP address that it can connect to the internet with. Our individual devices have their private IP addresses, and they can talk directly to each other. They don't have to route. They could go through a small switch device and they could just talk like that. They don't have to have their messages routed. They don't have to have their files or anything routed because they're all on the same internal private IP address. But as soon as they go through this router, that private IP address is going to have to be routed to the public IP address. So we have to make sure that we know the difference between our private IP address range and our public IP address range, so that when we're looking at an IP address, when we're seeing the difference between a public network and a private internal network, we can identify these addresses. We can identify which ones are public, which ones are private, because we know the ranges and we know which addresses are private and which ones are public. We mentioned that we have our public addresses versus our private addresses, and we know the difference now. We know that our public addresses are our addresses out on the internet that can be globally routed, and our private addresses are our IP addresses on our internal network that are not routed and we can reuse in different private networks. So what are our private IP address ranges? Well, our public addresses are going to be any address that is not in our private address range or isn't a address that is specified or reserved for another function, such as 127.0.0.1. Our 127 range will be a range that is used for localhost. So that's not going to be a public range. That's not going to be a public address or a private address. It's just going to be our localhost address. So addresses like that aren't going to be included, but any of the other public address ranges that we talked about earlier that are not a private address that we're going to cover are available to be used as public addresses. But as we said before, we're running out very quickly and have pretty much run out already. So our private address classes, we're going to take from our Class A, Class B, and Class C, and we're going to go over our private address ranges and talk about the subnet mask that they use, the CIDR notation that they use in order to get these ranges. But we're also going to talk about how this subnet mask is a little bit misleading, especially for our Class B and Class C. That's going to only identify the range of addresses that can be used for a Class B or Class C IP address, not necessarily how we would address those ranges or how we would actually put in their subnet masking if we were using a standard default classful IP addressing. But we'll talk about that in a second. Our Class A, Class B, and Class C, from our Class A range of IP addresses, our private addresses are going to be anything between 10.0.0.0 through 10.255.255.255. This is going to leave us with a subnet mask of this range of 255.0.0.0 or a CIDR notation of -8. We'll mention CIDR notation as well in just a sec. Class B is going to be any addresses which are within the range of 172.16.0.0.0 through 172.31.255.255. Class C is going to be any IP address between the range of 192.168.0.0 through 192.168.255.255. We have here in our Class B and Class C address ranges that are what we have as our subnet mask. Don't want to get too confused. 255.240.0.0, also known as -12, and 255.255.0.0, or also known as -16. Now, these subnet masks are really only identifying the range or the chunk of addresses that we're stealing, quote unquote, from the public IP address domain that can be used as a private address. If you were to take a Class B address, if you were to take an IP address of 162.16.0.1, and use a subnet mask of 255.240.0.0, we would actually be doing something called subnetting, which we'll talk about in a little bit. If you're using a Class B address as an actual address on a system or as an actual address as a network, the default subnet mask when you're addressing is going to be, which we talked about a little bit ago. So for Class B, our default subnet mask is going to be 255.255.0.0. I can feel that this still needs a little bit further explanation. So think of it this way. Our IP address, our private IP address range are 172.16.0.0 through 172.31.255.255 is our range of potential IP address, not only our range of potential IP addresses for our hosts, but it's also our range for potential IP addresses that we can use for our networks. So if we have multiple, say we have a network with multiple internal private networks, and we have a router with a single public IP address. So that router has to translate its public, or the public traffic coming in from the network to the different private networks. Now, we may want to have more than one private network. We may want to have, say, a private network for our small home office with our laptop and our desktop and our couple different devices. And we want to have a different private network for our home entertainment area where we use a PC in order to keep track of all the movies and things that we have and that we've purchased and downloaded or purchased and put on disk. So we have these two different networks. Now, if we use both of these networks on the same IP address network with the same subnet mask, then they're going to be able to talk. They're going to be able to talk without having to have their traffic go through our router. But that's not what we want. Maybe we want to sort of segregate these networks a little bit. We don't want them just talking directly back and forth through our switch. We don't want these devices talking back and forth directly. So we put them on different networks. Let's take our Class C addresses, because it's a little bit easier to understand with our Class C. Now, our Class C default IP address subnet mask, when we're actually doing IP addressing, our default Class C is going to have a subnet mask of 255.255.255.0. That's going to be the subnet mask we give our Class C addresses. So we're looking at our private IP address range. We're looking at all the potential private IP addresses that we can use. And we can use anything from 192.168.0.0 through 192.168.255.255. So we can use anything in that range. But we look here, and our default subnet mask for our Class C addresses, when we're actually doing our routing, when we're creating our networks, is going to be a subnet mask of 255.255.255.0. So we've talked about how an IP address of 192.168.0.1, when we line it up against our subnet mask here, we just take all of our 255s and we say, okay, we have our first 0 here. So that octet which lines up with our 0 and our subnet mask is going to be our host ID. And everything before that is going to be our network ID. Well, if we wanted to put set up another private network on our home, in our business, we wouldn't have to necessarily jump up to a different class of addresses. We could simply do IP of 192.168.1/.1.1. Now, when we line this up against the same default Class C subnet mask of 255.255.255.0, we put the slash before the last octet, and we say, well, wait a second, that's the same host ID. I thought we said we can't have the same host ID in the same network. Well, just because it's in our home, just because it's in our office with our other device, it doesn't mean it's on the same network. We see we have a different network ID. 192.168.0 is a different network than 192.168.1. These are still both private addresses though, because our Class C private address range includes both our .0 and our .1. But when we're actually doing our addressing and we're actually setting up our networks, we're going to be using for our Class C a subnet mask of 255.255.0 or 255.255.255.0. And for our Class B networks, we're going to be using a subnet mask by default of 255.255.0.0. Now, we took a look at our Class B range, and we see it has a -12. Now, we'll talk about that -12 and what that means in a little bit with CIDR notation, but all you need to know is with this Class B range having a -12, that gives us additional networks that we can set up with our Class B, but still have our hosts divided into different networks, but still be within this private range. So we took a look at our Class C. We said for our Class B, our default subnet mask is 255.255.0.0. So if we have an IP address of 172.16.0.1, then that means that our network portion, our network ID, is going to be 172.16. We have another device on our network of 172.18.0.1, and this device is now on a completely different network. It's on our 172.18 network. So don't get these two confused, or these different masks confused. You want to worry more about our default masks for our classes when we're setting up our networks than you want to be concerned about our masks that we're using when we're stealing addresses from our public range, because the default masks that you're going to be using for our classes, so our Class A, Class B, and Class C, you're going to be more concerned with knowing that Class A IP addresses have a default subnet mask when you're using them in addressing of 255.0.0.0. Class B addresses have a default subnet mask when you're using them for addressing of 255.255.0.0. And Class C addresses have a default subnet mask when you're using them for addressing of 255.255.255.0. It's critical to remember these three because we're going to be using those again, and they're going to come up again when we're doing subnetting. You need to understand that when we're taking an address, when we take an address in our Class A, B, or C range, and we're using a different subnet mask than our default subnet mask here, we're changing the dynamics of the way our networks and our hosts are set up. But that'll come up again in subnetting. So don't get confused by these. Our Class A isn't too difficult, isn't very confusing, but don't get too confused by our Class B and Class C when you see this -12 referring to, and I know I've beat this up, and I know I'm just beating a dead horse now. Our Class B and Class C ranges, these masks that you see just refer to the bits that we're using when we're stealing, are just referring to our bits and our IP address that we're using when we're stealing this range from our public range. So just be careful. Don't get these confused with these over here, our actual default classful addressing subnet masks, because these are what are going to be important to know and remember when you line them up and when we're talking about subnetting a little bit later.